Which of the following correctly shows trapezoidal approximation of the area under the curve represented by f of x equals to x cubed minus 2.1x plus 1.3 on a closed interval 0 through 4 using 3 subintervals. Step 1, we're going to calculate the width of each subinterval. So delta x is equal to 4 minus 0 divided by 3. So the width of each subinterval is going to be 4/3. Step number 2, we divide the function into 3 trapezoids, and each trapezoid will have equal width. So our first trapezoid goes from 0 to 4/3. That's the interval width. Our second trapezoid goes from 4/3 to 8/3. And then the third and final trapezoid goes from 8/3 to 4. Our next step is to calculate the area of each trapezoid. And for that, we're going to use area is equal to 1/2 times the height times the sum of the parallel sides. Now, keep in mind that the interval width, 4/3, is going to be the same as the height. So throughout all these problems, h will always equal the interval width. So the first trapezoid, the vertical length is f of 0, right here. And the second parallel side is going to be f of 4/3. Our second trapezoid starts at f of 4/3, and the second parallel side has a vertical length of f of 8/3. Our third and final trapezoid is still going to be 1/2 times h. It starts at 8/3, so the vertical length is f of 8/3, and then the final leg is going to be, the vertical length is f of 4. And I just want to point something out. You'll notice here that we have f of 4/3 occurring twice. And you'll also notice that I have f of 8/3 occurring twice. The reason why I'm making a note of that is we're going to find the sum of these 3 areas. So we're going to add all this together. So the 1/2 h gets factored out. And so we have 1/2 times 4/3. Remember, h is our interval length. So we have f of 0. And then you'll notice I have 2 times f of 4/3 because that occurs twice. And then I also have 2 times f of 8/3 because that occurs twice, plus f of 4. So the correct answer is A.